Hello. Today we'll be doing Book 4, Proposition 6 from Euclid's Elements, which says that in a given circle, you can inscribe a square into it. Okay, so for it to be a square, it needs to have equal sides and equal angles, which angles also need to be right angles. So the first thing that we're going to do is a mix of a few steps, but I'm going to put it all into one. So we're going to take the center of the circle. We're going to call it point E. And then from that point, we're going to extend it to make the diameter. So you can extend it on both sides. And then from this point, we're going to use Book 1, Proposition 11 to raise a perpendicular from here. Okay, so we're going to call this point B, D, A, C. So I'm going to call this step DB is perpendicular to AC. They're also the diameters of the circle. So I'm going to use Book 3, Proposition 1, which allows me to take the center. I'm going to use Book 1, Proposition 11, which allows me to raise the perpendicular. And then Postulate 2, which allows me to extend the points. Okay. So the next step of construction, very simple. We're just going to connect all of these points through some nice lines. Ooh, these are looking good. Oh, it almost looks like a real square. Okay, so connected AD, AB, D, DC, and BC. We can do all of that very simply through Postulate 1, which allows us to connect points. Okay, so now we're finished with the construction. So we're going to try to prove that all sides are equal in this figure. So we're going to try to prove that all sides are equal and that all angles are right angles. So he first goes about trying to prove that all sides are equal. So the way he does that is he pulls out these two triangles. So I'll draw them down here. Not drawn to scale, but it's okay. So we have triangle AED and AEB. So the way that he goes about proving that these are equal is Book 1, Proposition 4. So he first says that AE is equal to AE, which is due to common notion 4, since they coincide with each other. So common notion 4. So then we're going to say that DE is equal to EB, which is because of Book 1, definition 15, which says that the radiuses are equal. So DE equal to EB. That is Book 1, definition 15. Next, we have two sides. Now we need to prove that the angle is equal. And we know that both of these angles are right angles, which makes them equal to each other. And we know that they're both right angles because in our first step, we made the lines perpendicular. And we know that in perpendicular lines, these will both be right angles. So we can just say that angle AED is equal to AEB because of statement 1. Easy. Okay, so now that we have this equal to this, and we have a common angle in both of them equal to each other, we can use the side angle side theorem from Book 1, Proposition 4 to say that these triangles are equal to each other. But we don't really need anything else in the triangle other than these two sides. So we're going to say that AD is equal to AB. So this is due to Book 1, Proposition 4, which is the side angle side. So proving that AD is equal to AB, you could do the exact same thing on every side, since it's all going to be equal, since it's about the diameter and it's cut right in the middle. at the same points. So you could do the same thing to say AD is equal to DC, BC is equal to AB, and then combination one, all of it. But I'm just going to skip all of that and say that it is an equilateral. I'll just say ABCD is equilateral. And for my reason, I'm just going to say similarly, because you would use the exact same steps as you use to prove that that was equal. Okay, so now that we have all of the sides being equal, the next thing that we need to prove is that all of these angles in the square are right angled, because they have to be for it to be a square. So we can use book 3, proposition 31, to say that this angle is a right angle. Because book 3, proposition 31 says if you have a semicircle, which this is the diameter, so that makes this a semicircle. In a semicircle, any given angle or any given point on it, there's a right angle at that point. So we can say that angle DAB is a right angle because of book 3, proposition 31. And since these are all the diameter, all of these sides are semicircles, so that means this point right here is on this semicircle, so that makes it a right angle. On this one, so that makes that a right angle. On that one, so that makes that one a right angle. So I'm just going to say that all angles are right. Are right. And it'll be the same reason, book 3, proposition 31. So now we know all angles are right and all angles are equal to each other, and we know that it's an equilateral, all of them are equal to each other. So according to book 1, definition 22, we have successfully inscribed a square into ABC. We've successfully inscribed a square into a circle. And we know it's inscribed because all 4 points are touching. Now, QEF.